In this video, we're going to talk about series and summation notation. So let's start off with what in the world is a series. So let me start off by writing it a little bit more clearly. A series simply is just when you add together the terms of a sequence. So when you add the terms of a sequence. And you're going to find that the hardest thing about a series might be just understanding the notation that we use for a series. It's actually a really simple concept. There are two types of series. There are finite series, which look like this. Let's just say I have a sequence that has the numbers 2, 4, 6, and 8, and it ends at 8. If it's a series, all we do is add them together. That is a finite series. Then there are infinite series. These are series that go on forever and ever and ever. So let's say I have the same numbers, 2, 4, 6, 8, but it goes on and on and on. Here we would add all these terms together, but it keeps on going. We would just keep on adding those evens over and over and over again. So it gets a little bit clumsy if we had to actually write out all the terms of a series, or to write out what the whole series is, because it could be adding quite a bit of things together. So we have to have good notation here, and the notation that we use is called summation, because it's a sum, summation notation. So summation notation uses the capital letter in the Greek alphabet, sigma, to let you know that we're talking about a series or a sum. So the sigma basically looks like that. It's like an E. And let me just give you an example of how I can rewrite this finite series that we have up here. So like if I wanted to write 2 plus 4 plus 6 plus 8, using this sigma notation or summation notation, I would say, okay, I'm going to add up all of the numbers starting from an input of 1 to 4, where my sequence is defined as 2 times I. Let me kind of talk about this for a second. If you kind of notice this, the 2, 4, 6, and 8, if I'm inputting 1, this is really 2 times 1. If I'm inputting 2, this is 2 times 2. If I'm inputting 3, this is 2 times 3, etc., etc. The ith term, instead of using a sub n, let's use a sub I, the ith term would just be 2 times whatever I is. So this general rule goes here. That goes in the summation notation. And this I here, this is called our index of the summation. Index of summation. And this number here tells you the lower limit of your index, and here this is your upper limit of your index. So for instance, we're plugging in an index of 1 at the lowest, which gives us that sequence term 2, to a highest index of 4, which gives us the 2 times 4, or that number 8. That's the highest we want to go in this summation. On the other hand, for an infinite series, if I had to write this using summation notation, let's just do it over here. Here, I would use that notation, the sigma notation, start I still at 1, but now since I have the dot, 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 we're not stopping at the 4th term. We want to go on forever. So we're going to go up to infinity. That's going to be our upper limit. And it's the same rule. We're still looking at just 2 times whatever the input is. So that's just a little bit of the notation. One of the biggest things in this lesson is just going to be writing a series in summation notation. And let's look at two examples together. Let's call this example 1. And we're going to write the series in summation notation. Once you get the hang of it, it's pretty straightforward. But the initial first few examples are scary. So let's look at the series. Let's say we have the number 25, add the number 50, added to 75, and we keep on doing this until we get to a final number of 250. The first thing you're going to want to do is see if you can think of what is the sequence that leads to these numbers, kind of like what we did in the previous lesson. So we have to think, what are we doing to 1 to get to 25? What are we doing to 2 to get 50? What are we doing to 3 to get 75, etc., etc.? Well, it looks like we're just multiplying by 25. So if I did 25 times 1, and 25 times 2, and 25 times 3, and this last term I think is just 25 times 10, we would get this sequence. So in general, a sub I, let's use that I instead of n, would be just 25 times I. Now, we have to be kind of careful here because our inputs or our domain, I, starts at 1. That's our lower limit. The lowest I value we're plugging in is 1. And the biggest I value we're plugging in ends at 10. And it stops there. So this is going to be our lower limit, and this is going to be our upper limit. So if I had to use the summation notation, I would go from an I value of 1 all the way up to 10 for 25 times I. That means we're going to add up all of the terms from 25 to 50 to 75, 100, all the way up to 250, and that would be our notation. We're not actually asked to add them up. We just have to kind of write it in the correct notation. Let's look at another one. B. Let's say we have to add the following fractions together. 1/2 plus 2 over 3 plus 3 over 4 plus 4 over 5 plus, and it just goes on forever and ever. This is an infinite series. So we have to think, all right, if we're plugging in 1, how are we getting 1/2, right? If we're plugging in 2, how are we getting 2/3? If we're plugging in 3, how are we getting that? If we're plugging in 4, how are we getting that? And it just looks like if we plug in 1, the denominator is just 1 larger than it. If we're plugging in 2, the denominator is just 1 larger than 2. If we're plugging in 3, it's just 1 larger than 3, etc. 4, and then we just have to add 1 and get 5. So in general, if I have an input I, we're going to get I in the top, and then 1 larger than I, or I plus 1 in the bottom. It kind of makes sense. If you plug in 1, you're going to get 1 over 2. If you plug in 2, you're going to get 2 over 3. So I think this is our rule where I starts with 1 and goes on to 2, 3, 4, and it does not stop. It doesn't have a final it doesn't have a final term somewhere over here. It just has ... So this is an infinite series that I would write like the following. I would use my sigma notation. I starts at a lower limit of 1, and since it goes on forever, the upper limit we're going to write as infinity, and we can just say it's I over I plus 1. So that's the first thing that we're going to have you try to do. The second example that I would like you guys to be able to hopefully follow and do well with is actually just like kind of adding together some of these series. The first thing to note is the index of summation can be any letter. It doesn't have to be I all the time, and it also can start with a lower limit other than a 1. So you don't have to start with 1 and then go up to some upper limit. It can start with something else. Let's do an example of such a summation. So for example, let's call it example 2. Let's find the sum, like actually calculate the sum of the following. So if I gave you the following sum, let's say instead of using I for our index, let's use k. So let's say k goes from 4 to 8, and the series is defined by 3 plus k squared. So we start with an index of 4 and we end with 8. Right away you should be thinking this is a finite series. So we can actually get a sum here. If it was infinite, the sum of all these would be infinite. Sometimes that's not always the case, but I think in this one it's going to be. So to do this, we have to plug in starting with a k values of 4. So if we plug in 4, we're going to get 3 plus 4 squared for our first term. Then the next term, let's write that in parentheses, we'd have to plug in k is 5. So the next thing we'd have to add is 3 plus 5 squared. And then we'd have to do, when k is 6, and add the term 3 plus 6 squared. And then we'd have to add the term when k is 7, so it'd be 3 plus 7 squared. And we'd have to end with the term where k is equal to 8, which would be 3 plus 8 squared. Now we just have to do some simplification. 3 plus 4 squared is 3 plus 16, right? So that would be 19 plus 3 plus 25, that would be 28. Then 3 added to 6 squared would be 3 plus 36, that would be 39. Then it would be 3 plus 7 squared is 49, that would be 52. And then we do 3 plus 8 squared, that would be 64. That would be, what's that, 67. And then if you used your calculator to actually add all of those together at that point, I think you get 205 for your total sum. Now, you could see, and we didn't have to add more than, what was it, 1, 2, 3, 4. These are only 5 different terms to add together. You can see it's kind of tedious if we had to add more than that, you know, in another series. So it does help to know the following shortcuts or special formulas. I'm going to show you on the next slide a picture of them. I would make sure you write them down separately so that you have them and you know them well.